Hello, and welcome to the Data Engineering Podcast, the show about modern data management. Data teams everywhere face the same problem. They're forcing ML models, streaming data, and real-time processing through orchestration tools built for simple ETL. The result? Inflexible infrastructure that can't adapt to different workloads. That's why Cash App and Cisco rely on Prefect. Cash App's fraud detection team got what they needed: flexible compute options, isolated environments for custom packages, and seamless data exchange between workflows. Each model runs on the right infrastructure, whether that's high-memory machines or distributed compute. Orchestration is the foundation that determines whether your data team ships or struggles. ETL, ML model training, AI engineering, streaming, Prefect runs it all from ingestion to activation in one platform. Whoop and 1Password also trust Prefect for their data operations. If these industry leaders use Prefect for critical workloads, see what it can do for you at dataengineeringpodcast.com/prefect. Are you tired of data migrations that drag on for months or even years? What if I told you there's a way to cut that timeline by up to a factor of 6 while guaranteeing accuracy? Datafold's Migration Agent is the only AI-powered solution that doesn't just translate your code, it validates every single data point to ensure perfect parity between your old and new systems. Whether you're moving from Oracle to Snowflake, migrating stored procedures to dbt, or handling complex multi-system migrations, they deliver production-ready code with a guaranteed timeline and fixed price. Stop burning budget on endless consulting hours. Visit dataengineeringpodcast.com/datafold to book a demo and see how they turn months-long migration nightmares into week-long success stories. Your host is Tobias Macy, and today I'm interviewing Mark Brooker about the impact of agentic workflows on database usage patterns and how they change the architectural requirements for your infrastructure. So, Mark, can you start by introducing yourself?
Hi, I'm Mark Brooker. I'm a VP and Distinguished Engineer here at Amazon Web Services, and I spend most of my time working on agents and frameworks for building agents, infrastructure for building agents, and also on our database portfolio, especially focused on transactional applications, NoSQL, and large-scale applications and serverless.
And do you remember how you first got started working in data?
So, I was working on the EC2 team in AWS. Back in 2011, and one of the things that we were doing was essentially being an amateur DBA team running our own database infrastructure. And that was painful in a bunch of ways. We ran these huge MySQL clusters of eventually thousands of machines. And as operationally painful as that is, and as much as I wouldn't want to repeat that experience, it did really give me a taste of what was exciting about databases and interesting about databases, and an inspiration for a set of problems that I wanted to solve on behalf of teams like mine and customers like mine. And it took another 9 years before, databases was really my day job. But those experiences running and operating and designing that fairly large scale system, really stuck with me. And I was very inspired to want to solve some of those hard problems. And so, folks like me, the next round of folks like me didn't have to worry about them as much.
And now the world has obviously changed a lot since 2011, especially in the technology realm. And for a long time, we've had a very established architectural pattern for the happy path of an application where the three-tier architecture gained a lot of ground, is widely deployed, well understood. And now we are entering a new era where agentic workloads are gaining prominence and utility, which turns a lot of our assumptions about usage patterns, traffic patterns, persistence requirements on their head. And so I'm wondering if you could just start by giving your understanding of the role that the database plays in I'll use the term typical, although that it's still a very evolving space, a typical agentic workflow.
Yeah, obviously evolving space, very exciting amount of innovation going on in the agent world right now. And, it fundamentally, agents and generative AI and AI more broadly is a data game. Data is the core of training. It's the core of model building, but even more so at inference time, at generation time, at agent runtime. Access to data is how these things are successful. There's no way for you to build all of the relevant data into a model. You couldn't do that. You wouldn't want to do that because of access requirements and so on. And so data really is at the core of these AI architectures in the same way that it has been in the core of that traditional 3-tier architecture and the architectures that came before it. If we look at the agent space specifically, there are a couple of different cases, right? I think about data for agents to use, right? This would be the case where, you have a business intelligence agent, for example, and you say, go and find me 5 interesting things, or go and find me the 5 customers who grew most in the last week and what was common about them. And there's a set of access patterns related to that, which I can go into. And then there is agents as builders, right? Agents as developers, agents as things that are either autonomously or much more commonly working with humans to build architectures in the cloud. And here they could be building architectures of other agents. But even more commonly, they're building architectures that look like, from a block diagram level at least, the more traditional architectures, right? They're building those microservices. They're building those SOA services. They're building those backends for websites. They're writing that React code. They're writing that Java code. They're writing that Rust code. And the access patterns aren't that different. The access methods might become quite different. There are big differences in requirements for things like authorization and authentication. But what is very different is the operational requirements. How do you know if the database is scaling? How do you know if it's healthy? And those requirements really have moved on. And so, broad space. And then maybe I might think of a third set of agents, with the agents that are operating my as-built cloud infrastructure, right? That are looking at it and saying, is my latency good? Is my cost optimal? Are my customers having a good time? And, if those things are no, then, making changes to the system, scaling things up, scaling things down, adding capacity, removing capacity, reconfiguring, and so on. And so with all of those agent use cases, there are different ways that they're affecting data access patterns, but all of them, fundamentally still have their architecture built around data sets, whether those are data sets in traditional relational databases, whether they're data sets in things like graph and vector databases, or whether they are much more kind of open-ended data lakes where, there's a whole lot of data, some of it's structured, some of it's unstructured.
Another interesting aspect to the agentic workload pattern that I've heard anecdotally is that for the Neon serverless application Postgres database that was acquired by Databricks, as well as some of the databases that are available on services like fly.io, I've heard people say that the majority of the actual database instances that created are actually created by agents and not humans. And so they actually ended up changing some of their product roadmap to be able to optimize for those use cases and those usage patterns beyond just the human driven, I need a new database for my application and I'm going to create it one time and that's all there is. And there will be a fairly monotonic level of increased usage, but it's not going to be as spiky as some agent that is maybe spawning off dozens or hundreds of sub-agents to do various workloads and store their state somewhere. And I'm wondering, in terms of the agent workload patterns, some of the behaviors that you've seen that are typical in terms of the means of allocating and interacting with that persistence layer.
Yeah, obviously I can't talk to the accuracy of those reports, but it's certainly true that this agent as builder is changing the way that people think about the requirements of database systems, and especially relational databases. And agent as operator too. And, if you think about, well, what's different? You look back in time, a database was, this very specialized piece of hardware. I would order it with months of lead time. I would install a piece of software on it that I got from a vendor. It had a single license. I'd spend potentially weeks setting it up and tweaking it and getting it, ready for its workload, do a bunch of testing. And so often the lead time, even if we look back 20 years ago, the lead time for database provisioning was months and, maybe at best weeks, best case days. What happened with the cloud is bringing that down to hours and then bringing that down to minutes. And now with serverless really started this push, but agents are accelerating it. Folks want to say, I want a relational database. I want it to have this data in it. And I want it to be available in seconds. And then I'm going to use it. Maybe I'm going to use it forever. Maybe I'm going to use it for minutes. Maybe I'm going to use it for hours. And that has to be economical. And then if it does run for a long period of time, it's got to be able to deal with that scaling. It's got to be able to deal with failures. It's got to be able to keep itself up to date. It's got to be able to keep itself secure and patched. And so if you look at what we've been doing at AWS with DSQL, where all of that patching and all of that scalability is built into the product, it's not something the operator needs to worry about. And in Aurora, where we've been improving automatic patching, reducing the downtime, significantly accelerating the creation of databases, both for Aurora DSQL and Aurora Postgres, significant scale up and scale down work, creation time work, pricing to make these more dynamic data use cases viable for customers. A lot of that has been accelerated by agents and the needs that these agents as builders and agents as operators have, and the requirements that they're pushing on database vendors. Super exciting time in the data space because of this, right? As an engineer, right, the hard problems, my motivation to solve hard problems is inspired by my customers. And this rate of change is just a super exciting time. It's also kind of fulfilling as somebody who spent a lot of time working on serverless, working on Lambda, growing that business and really seeing the serverless trend grow and seeing the customer value that's brought. This is an acceleration of the things that folks were caring about in that serverless space. And so, great innovation going on kind of across the industry. And I think as agent as builder becomes a more and more ubiquitous pattern in the industry, we're going to see this as become a set of hard requirements for database products. And that applies to relational and non-relational databases.
The other interesting aspect is that for somebody who is architecting their own application from scratch, they will typically have a certain set of requirements and constraints that will guide them into determining one of, or possibly multiple of, a particular set of categories of database, whether I'm going to be using a relational database because I'm going to be largely transactional in terms of my usage patterns, or maybe I need a document database because of the flexibility of input and not knowing exactly what the type of data is that I'm going to be storing, or maybe I just need a key value store because it's a very simple usage pattern. And as you bring agents and their autonomy into the mix, I'm curious how you're seeing that change the calculus that teams have as far as determining what are the persistence layers that they want to expose to those agents for being able to manage their own state or build their own systems and use cases that the orchestrator agent is maybe federating out to sub-agents.
And so if I think about persistence needs, there's some things that are new and some things that are just not new. And I'll start with the not new, right? Like choosing the right database has always been an exercise in understanding the shape of your data and understanding the needs of your access patterns. And so if you have data that is, structured, having a schema, putting it in a relational database can provide incredible benefits in terms of being able to normalize and being able to enforce business constraints at the database level. However, if that data is unstructured documents, putting it in a relational database might give you a place to index it, but isn't buying you a whole bunch of value. And so you could put it in an object store, like S3. If your data is fundamentally graph shaped, putting it in a graph database can provide some really beneficial different ways to access that data that can really help applications. And I think where people get into trouble in the data space is following trends and thinking about, oh, well, graph databases are hot right now, and so I'm going to take all of my data and try and force it into that shape. Or, everyone's talking about object stores right now. I'm going to take all of my data and try and force it into that shape. And that doesn't work. I mean, frankly, there is a reason that, there are these decade-long durable patterns for different ways of structuring and accessing data. Obviously, relational databases and SQL are super powerful and super flexible. And typically, when I talk to people about their architectures, I recommend that that's the kind of first place they should look, right? If you're unsure, hey, look at relational, look at SQL. Does it fit into that model? But it isn't the be-all and end-all. And certainly there is space for NoSQL and for key value and for graph and for object and for document and, all of these other different, structures and access patterns. And so those are the things that haven't changed. And then the things that have changed is what we've seen with AI over the last 5 years or so is this real emergence of new access patterns and new access methods. And, probably the most interesting one of those is vector. And, if you had said to me when I was studying computer science that, we would have robust ways to take a piece of text, extract the meaning from that text, turn that meaning into a set of numbers, put those numbers into a multidimensional space, so that, other pieces of text with similar meaning would be nearby in that space, right? I would have thought that was science fiction, but that is the way that vector databases work. And what makes it so powerful, what makes this idea of, I'm going to take text, I'm going to turn it into these numbers that express honestly just meaning. And when I look it up, I can say, show me the bits of text that are related to this one semantically, that mean similar things, that contain similar concepts. And that's new. I mean, in a theoretical sense, it's not new. There's a set of techniques that has existed for 30 plus years. But the emergence of that as a mainstream technique is new. A mainstream technique that is powering, everything from semantic search to RAG, to a whole lot of more emerging database techniques. And again, the place that folks are getting into trouble with that technique is to say, well, vector is the only thing you need for AI. And so I'm going to take my data of whatever shape it is, and I'm going to try and force it into a vector database. And clearly that doesn't work, right? There is still data that is relational, data that is graph, data that is documents, data that is, keys and values. And there is nothing inherent to AI, generative AI, agentic AI, that stops them from using those other access methods, those more traditional access methods, very efficiently and very effectively. And so vector has given us another tool in the toolbox rather than a replacement. And that tool has, in turn, enabled a whole bunch of new techniques, like RAG, like graph RAG, that have, allowed AIs to become more useful and more powerful, and more easily consume data that isn't in the training set or the fine-tuning set. And so, yeah, I mean, that's what's kind of been happening in that access space. But I do expect what we're going to see is some of the, flashy newness around vector kind of settle down, and, us go to a world where we have this new tool in our toolbox. But a lot of the agents we're building are using relational interfaces. They're using those document interfaces. They're using lookup by primary key, lookup by secondary index. They're using looking up by geo. All of these things that have existed in the database space for decades. Oh, now we also have this one more, which is kind of lookup by semantic meaning, which is very exciting and new and powerful.
Another interesting aspect of the decision process for which style of persistence layer you want to use is the capability of the model that you're using, where particularly a couple of years ago, a lot of models could not form properly structured JSON to save their lives. And also there was the initial advent of text to SQL, but there was a decently high failure rate for that. One of the reasons being that SQL is based on mathematical primitives, and LLMs are hilariously bad at math, or at least have been up until the past year or so. And I'm wondering how you're seeing some of those considerations factor into the style of persistence that somebody might select for either a particular model or a particular style of agent.
Yeah, so I think there are two things that are going on there. Certainly one of them is an improvement in model capabilities. Models have become significantly more capable over time. We have, as you pointed out, seen this real improvement in reasoning or something like it from models. These models that can go off and think and talk to themselves for a little bit and kind of noodle their way through problems. And that's been led to a new set of capabilities. Models certainly have gotten better at outputting data in certain forms. You want JSON, you want XML, you just want stuff that's tagged in a certain way. They're actually pretty good at that now. Certainly not infallible, but have improved markedly over the last year and made some things possible that were very difficult before. The other thing that's happening, I think this is a bigger trend and almost more important than the improvement in model capabilities, has become the mainstreaming of tool calling as a pattern. We've seen that with MCP, we've seen that with A to A, we've seen that with these, agentic frameworks where we've been able to give models tools that they can use and describe those tools in a way that will allow them to choose the right tool. And so, if you say, hey, I want this JSON data as a CSV, that's something that a Python program, you could write that in probably, 3 lines of Python, and get great performance. You could write that in probably 10 lines of Rust and get fantastic performance. You did that with an LLM, it would be many orders of magnitude more expensive and many orders of magnitude slower and more fallible. And so, being able to say, here, LLM, here is a code interpreter that you can use as a tool. And so if you run into one of these problems, instead of trying to noodle through it yourself, write that little piece of Python code and execute that. Or, here is a database API, or here is a microservice API as a tool, right? Here is a SaaS application as a tool. And you can use those things to access data in a structured way. And models have become much, much better at selecting those tools, calling those tools in a successful way, knowing when the tools are the right things to use and when they help. And so if you look at even, the cutting edge research on, or the sort of frontier of models and the frontier of reasoning, what you're seeing in the benchmarks isn't, hey, this is just the model doing it itself. It's the model doing it with a tool and often with a code interpreter. And sometimes that code interpreter has a scientific library, maybe a symbolic math library. Certainly it's got CSV parsers and JSON generators and all of these other things that are, super powerful. And so, you asked about something like NL to SQL. You certainly do still need the ability for the model to think, hey, what data do I want from this database and what schema is there? It's gotten better at doing that, but we've also gotten better at saying, here's a tool that is a specialized interface for running these kinds of things, for maybe accessing data with the right structure, maybe hiding some of the complexities from the model that it doesn't need to worry about. And, that has provided a whole new set of capabilities to people who are building end-to-end systems with models. It's allowed us to use bigger and more capable models because we can do the heavy lifting of data movement in, plain old boring code. And in turn, that's helped, spin the flywheel of, hey, you've got a more capable model. It's better at using the tools. It's better at building its own tools when it needs to. And so I think that the combination of those model capabilities and tools and tool calling are, really spinning the flywheel of models and agents right now. And I think what we're going to see is continuing improvement on both of those things. But I believe that, the tool calling side and, figuring out which tools are most useful, making those tools available to models is going to have, probably be the bigger deal over the next few years than model capability improvement.
Another interesting aspect of persistence and state management in the context of these models and agents is that the models themselves are effectively stateless, where every single time you make a request to them, you have to be able to provide them with the appropriate context or pre-existing state for them to be able to do anything useful, because they don't have any actual memory beyond some tertiary persistence layer that they might rely on for being able to retrieve additional context. And in terms of the actual runtime of the agent or the LLM, because of the fact that every interaction is an API call, there is no real benefit to maintaining persistent state within the process that is mediating that interaction, aside from network latencies. And given your experience working on the Lambda toolchain for AWS, I'm wondering how you're thinking about the benefits and trade-offs of using something as ephemeral as a Lambda for something as ephemeral as an LLM call, and the varying layers of persistence and network retrieval, et cetera, in terms of that overall interaction pattern.
Yeah, I think it is really interesting, the sort of parallel between Lambda style stateless functions and the statelessness of LLMs. But while it's true that these LLM calls are pretty much stateless, except for things like prompt caching, which has started to introduce the soft state into LLM interactions, the agents themselves, the agent code has a lot of ongoing state. It's got a lot of memory. And so if you build an agent with a framework like Strands or a framework like LangChain, there is a bunch of, just variables, stuff that it remembers as it's doing an LLM step, and then maybe a tool call, and then maybe integrating with something else, and then, going back to the LLM. And so I think, short-lived single-shot agents, Lambda can be a great fit for those kinds of workloads. But a lot of agents aren't like that. They're longer running. They've got more state. They're using, more imperative code inside their agent frameworks. And that's where, a couple of months ago, we announced and shipped the preview of a set of capabilities of AWS, new capabilities called AgentCore. And one of the pieces of AgentCore is the AgentCore runtime. And you can look at AgentCore runtime, and it looks, in some senses, a lot like Lambda, right? It is this, completely serverless runtime for just chunks of code. You can bring a container, you can bring some code, you can bring your code in your framework, and we can run it. But unlike the Lambda product, AgentCore runtime calls can run for hours, and they are isolated in different ways. I'll talk about sessions in a minute. But this allows you to build an agent with a framework like Strands, with a framework like LangChain that runs for a long period of time and mixes LLM interactions with tools, with interactions with other services, with imperative code, with local communication, and all of the other things. Like, it lets you sort of pull from the toolbox, basically whatever you want for agent building. But, the one of the huge benefits of Lambda has been that single shotness, right? The relative statelessness is a powerful tool for thinking through the security model of Lambda functions. And so we wanted to keep that. And so what we did with AgentCore runtime was every agent session, and so you bring a session ID and you say, this is, my interaction with this agent, gets its own micro VM, gets its own environment, gets its own strong isolation from all other sessions. And so if I'm interacting with an agent for a task at home and for a task at work, those are strongly isolated. If you're interacting with an agent and I'm interacting with an agent, those are strongly isolated in AgentCore with VM isolation, right? Like, there's a real security boundary. And the combination of these things, this fine-grained isolation model at the session level, and the ability to have these sessions run for hours and hours, relaxes some of those constraints that you would think of if you had something like Lambda, while providing a lot of the similar benefits, both operationally and security-wise, that you would get from a serverless compute runtime. And that's really been the goal of the team, is to provide both of those things as we build these primitives for running agents. But as I said, there's nothing magic about agents, right? There will be some agents that are a great fit for AgentCore runtime. There'll be some agents that are a great fit for Lambda, and there will be some agents will want their own 192 core box with a terabyte of RAM, and you'll buy them a whole EC2 instance to run on. And I expect that over time, we're going to see agents of all shapes and sizes that fit essentially across the whole of the current compute ecosystem.
The other aspect of agents is that because there's not necessarily any human associated with it, their usage patterns, both in terms of frequency, but also in terms of distribution, are unbound from physical constraints, which brings me to the DSQL project, which, to my understanding, is a geo-distributed, horizontally scalable relational engine. And I'm curious how you see that fitting in with this overall use case of expanding the autonomy of these agentic workflows and their ability to operate at the various geo-replicated locations that are most conducive to the particular task that they're trying to perform for a given end user.
Yeah, I think there is a lot of overlap between those requirements and the needs of agents. And so I'll start with DSQL is a about a year old, slightly less, about 10-month-old product that we announced at reInvent last year. It is a serverless relational database. It's Postgres compatible, scales up and down. It scales down to 0, scales up to essentially, whatever size you need it to. Serverless operations, right? There are no boxes. All of the patching is done for you. All of the failure tolerance is built in. And, it can run in this optional mode where instead of being only fault tolerant within a single AWS region, which offers a great level of fault tolerance already, can also run across multiple AWS regions with a full replica. And that means that a whole AWS region can become unavailable and your database can still keep going with strong consistency, with no data loss, and close to the customers that matter. And those things are obviously important for traditional applications, right? If you think about highly regulated industries, you think about financial industries, you think about things like retail, where having the business be available, no matter what happens is critical. And those were the workloads we really had in mind as we were thinking about DSQL and thinking about kicking that off. But, as agents have emerged, a lot of the same requirements have been there, right? Like the operational requirements of, I appreciate not having to patch. I appreciate not having to worry about failures. I don't need something to fix things. It's just this endpoint that my agents can use that is always available. Then, as you said, while they're unconstrained by these constraints of the real world, they're unconstrained by the constraints of humans. And so we should expect that agentic workloads are much spikier in scale and in time, right? Like, hey, I want to go and ask 10,000 agents to cluster around a problem. They're going to work, maybe do, millions of transactions a second for a few hours and then nothing. And so that scalability becomes super important. The pay-as-you-go pricing model becomes super important. The ability to handle both big data and small data becomes super important. And then, as you say, there's also geography to think about with that. And there are two aspects to geography. One of them is because of the demand for inference, some workloads are needing to go, geographically where there is inference capacity available for them. And so having the flexibility to say, I'm going to run this interesting agentic workload closest to the most economical inference capacity is a real differentiator for a lot of workloads and is practically very, very useful. The other thing with geography is about being close to, those human end users, giving people really quick access to the data they need, the results of their agents. And, and so having the ability to have a strongly consistent database, have a fault-tolerant database, and to have a database that is global in multiple AWS regions, potentially on different continents, is extremely powerful and extremely useful in providing yet another flexible building block for agents to use. And so, again, like those workloads are not new. They've been workloads that have been in the background, but they're becoming much, much more mainstream as agents drive a new set of access patterns and new different kinds of architectures. Both the needs of running agents and the needs of running the architectures that agents are building.
And you've also been involved, to my understanding, with the Kiro project, which is Amazon's new entrance into the agentic development ecosystem. And so that gives you a different perspective on agents that are operating more in a local mode versus in a deployed environment. I'm wondering what you're seeing as some of the common patterns and ways that they vary between those local versus deployed environments, and then especially given the context of our conversation, the ways that you need to think about state management across those boundaries.
Yeah, so Kiro is super exciting. Kiro is the IDE that we released about 2 months ago, and this core idea behind Kiro is this idea of specification-driven development. Is the idea of instead of having a tight loop with an LLM where I'm doing this vibe coding thing of kind of step by step asking it to do things, I instead, maybe with help of the LLM, write a specification. I write down what I want my program to do, what I want my service to do. And then with that specification in hand, the agent can have a lot more autonomy to go off and make long-term decisions, can see the bigger picture, can iterate on things, can highlight, hey, I actually didn't understand this bit in the specification. Let's go back and, fix this ambiguity. And so specification development really drives two things. One of those things is taking the, chaos of vibe coding and turning it into a much more repeatable software engineering practice. And the other is to giving the development agent a lot more context and a lot more work to take on at a chunk, therefore unleashing it to do a lot more. And doing a lot more could be doing it locally, or it could be doing it remotely. Right? You might want to say, hey, I don't want this running on my laptop right now. I want to close my laptop, go home, and have it continue the development task running elsewhere. And then you asked about local versus remote. And so if you look at the current MCP ecosystem around data, for example, everybody, including AWS, we started with local. And we started with local because it's easier, right? Because you don't have to worry about having this endpoint available to the outside. You don't authorization and authentication are much easier. Connectivity is much easier. You don't have all of the scalability challenges. Typically, those MCP servers, those local ones, can be simple single-threaded programs that are proxies around something that you already have access to on your laptop. The remote ecosystem is more complex, right? It has real authentication and authorization requirements. It has multi-tenancy requirements. Often those things will be exposed to the internet or exposed to large-scale corporate networks where they need web application firewall type controls. They need DDoS protection type controls. They need billing and quotas and, API definitions and all of these other things that real internet scale services need. And so, I think the whole ecosystem started local, but is going remote because remote is much more powerful and much more flexible, but the requirements are also hard, or also, higher, right? There's a higher bar to cross. And so the biggest trend, I think, is we're going to go away from as many local MCP servers to web services and SaaS services and all sorts of other services having, real remote MCP endpoints or real remote endpoints that LLMs can use as a tool call, authenticating on behalf of a human or authenticating as, machine to machine, fine-grained authorization and all of these other things. And so I think that is the trend. We're going to see this trend from local to remote over the next 6 months to a year or so as the protocols get more mature. And that's something that we're contributing to heavily at AWS, as offerings like our own AgentCore gateway get more mature and make it easier and easier to offer those remote MCP servers. So I think that's going to be the big trend. There is always going to be some stuff locally, right? Like they're going to be local resources I want to interact with locally, like my file system. Like this tar file I just downloaded, right? Maybe local data sets. Maybe I want to have some local data for dev and test, have a really tight feedback loop on development and testing. And so I think local will really be focused on dev and test, focused on tools that are powering the daily developer work, providing access to local resources. And then anything that starts to look like production data, starts to look like shared data, starts to look like multi-tenant data, I think is going to turn more and more into looking like a web service, but with, MCP instead of, HTTP REST as a way to make it easier for an LLM or for agents to call those resources. And I'm sure there's some innovation, that's going to go into local. I'm sure that there's going to be some innovation in those developer tools that, makes it easier to work with remote data sets locally and get the benefits of that. But I think we're going to see a very similar software development lifecycle in the agentic development world as what we see in the cloud, where, folks are developing locally, running simple testing locally, and then, there's a step out to a sort of real CI/CD pipeline where things are running against kind of real versions of services for integration testing and then final in production testing. The other part of that picture is obviously evaluation, which is this very sort of AI and agent specific problem where you want to ask these questions like, well, is my agent working? And the closer you can do that into production, the more high fidelity that answer is, right? Because it's running against the real services. It's running ideally with real data. It's running in the real environment. And so much like in the traditional software development lifecycle, the closer you test to production, the more bugs you find. I think we're going to see the same with evaluations. So there's a lot going on in that space. I think local will survive, but I think we'll see less emphasis on local than we have over the last 6 months or so.
And in your experience of working across these various tool chains and product suites, what are some of the most interesting or innovative or unexpected ways that you've seen the combination or in isolation usage of serverless and database systems for these agentic workloads?
This is where it becomes tricky because I have to think about which of the great customer stories I can share. But one of the things I really liked was the team that was developing DSQL invested a lot in fuzz testing of testing DSQL against Postgres to make sure that if you run the same queries, you run the same transactions, you get the same results. And built a quite sophisticated automatic fuzzer that could generate SQL. And then what the team realized was, they were thinking about, how do we add capabilities to the fuzzer? And one of the capabilities is to say to an LLM, hey, go off and generate a bunch of weird SQL, right? Go off and generate a bunch of weird transactions with weird costs and join orders and all of these other things. And, and then we can run them against these two databases. And so that was a case of using generative AI as an additional fuzzing technique as we tested that database, but also using agentic patterns as a way of running those techniques and looking at them. In a similar vein, I was talking to a customer just the other day who had built a really cool little agent to look at explain plans from Postgres and from MySQL and turn those into hints for their developers to optimize their code. And so they had taken this previous engagement, which had been an engagement between their teams and their DBAs, where they would have an expert go and look over a piece of SQL, which was time consuming and expensive and so often skipped, and then building that same expertise into an agent that they could use as part of their development cycle, run the queries with explain or explain analyze against the database, get back the plans, have the LLM and some fixed code analyze those plans for good practices and for optimality, and even directly suggest, send a code review for, you are running the query this way, you should run it this way instead, you'll get the same results in a tenth of the time, and save a bunch of cost in the database. And so that's the kind of development time innovation I think there's this huge explosion of. I think production workloads are earlier. There's a ton of excitement around those. But I don't have, great stories yet for folks who are, really seeing innovative, there are a ton of these great stories, but I don't think I have any to share yet of folks who are seeing, really great business impact from in production agents that their business users are interacting with and their end users their customers are interacting with.
And in your own experience and work of developing in this space and working to help your customers stay up to speed with best practices and evaluate the ecosystem, what are some of the most interesting or unexpected or challenging lessons that you've learned?
Yeah, so there's been a bunch of unexpected things. Like I think the relatively unpredictable curve of model capability has, caught us a little bit off guard. If you look at the sort of previous wave of agent building patterns, there was this really dichotomy of plain text agents of, hey, I'm just going to prompt, right? It's just prompting. I'm just going to ask the agent what I want to do. And purely imperative agent frameworks where you say, do this step, then do this step, then do this step. And then if you look at the newer sets of agent building frameworks like Strands, they get around the lack of power of the pure prompting approach by allowing you to bring imperative code, but they get around the fact that the imperative code wasn't really taking advantage of model capabilities by making that code much more declarative. And so it's much more about, hey, here's the thing that I want to achieve. Maybe I'm going to express that in natural language. Maybe I'm going to express that in code. And I'm going to have a lot more success building agents from that. And I think even a year ago, I think people would have been fairly surprised that that mix of declarative programming and imperative programming and prompting was going to turn out to be the most successful way now of building agents in general. Like, obviously, there are great success stories, across the whole spectrum of tools there. I think the other things that we shouldn't find surprising, but I think have caught folks off guard, has been the strength of some of those kind of, for want of a better term, fashion cycles, right? Hype. There was this huge hype about a year ago, maybe 18 months ago, around RAG, right? And RAG was going to be the be-all and end-all of data access patterns. And vector databases were going to be the only thing that folks used for Gen AI. And then, models came out with bigger context windows. And there was this whole trend of folks saying, oh, well, RAG is dead, right? We're just going to throw all the data in the world into the context window. Well, obviously, you can't do that either. And so, RAG isn't dead. RAG has just joined our toolbox as one of the ways, one of the patterns. But it also hasn't turned out to be the be-all and end-all. And so I think what catches people off guard is this blend of, what's really changing fast and what hasn't changed. And I think what hasn't changed is our data's particular shapes, right? There are values in modeling data in particular ways, right? Relational, this model that is ancient in the grand scheme of computing, remains very, very relevant to agentic applications today. And so I think that's what's going to keep catching the whole industry off guard. Is it's going to continue to be hard to predict what remains the same and what changes. Obviously, there will be some things that remain non-negotiable, right? The security of and privacy of my customers' data, that is going to remain critical to me and critical to them, no matter what else happens in the world. Agentic applications are going to have to make business sense, right? They're going to have to, do more than they cost, and that's not going to change. And so there are some things to stand on that we know are going to remain relatively constant, but it is going to remain quite hard to predict for all of the remaining stuff what is going to be replaced by something new and what is going to remain these sort of durable pieces of value, like the relational model, like the graph model, like the document model, throughout this whole kind of AI revolution. And yeah, it's going to be exciting to see, what happens there. Hard to predict. And, these hard to predict times are the most exciting times to be working in a space and innovating in that space.
Are there any other aspects of this overall topic area of persistence and the various agentic patterns and how they interplay with the need for storage and retrieval of information that we didn't discuss yet that you would like to cover before we close out the show?
Yeah, I think there's one other one that we haven't touched on, and that is this, emergence of object storage as being the go-to backend for data applications of all types. And so if you look, even though DSQL is this, very transactional focused system, it's this very OLTP focused system, the bottom turtle of its durability story is S3, right? It is object storage. We've seen the analytics and data warehousing and data lake world really sort of embrace object storage, embrace these formats for data in object storage over the last few years. And that has become the way that is done. We're seeing more and more vector databases and transactional databases and graph databases that are essentially smart optimal front ends on top of object storage as that durable store. And that makes a ton of sense just as an architecture, as a cloud architecture, as the end point, I think, of a lot of, 20 years of cloud innovation. But it's also super convenient in this AI world because, as I started off with, AI is fundamentally this data game, right? Like, it is fundamentally a thing that gets better with access to data. And if you have all of that data together in your object storage in a format that it can be accessed together, that data is much more powerful for building applications, for training models, for fine-tuning models, and for access from agents and access from architectures that agents are building. And so it's a trend that I think is going to turn out to be long-term just super valuable and one that's very aligned with the needs of AI, but also a continuation of a trend of innovation that has come from 20 years of cloud architectures and large scale architectures and iterating on those things. So that's another thing that I'm really keeping my eye on. We're investing in here at AWS and making sure that, our customers and their customers have easy access to all of their data, and through access to data through the right interface for the right structured data, which really has been the key to success in this industry for its entire 4 decades of history.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Yeah, tooling and technology. I think there are a couple of gaps. One of them is we still haven't, reached this ideal of simplifying business user access to all of the data that a business has. Right. When I see folks around me, even though, at AWS, we have quite a sophisticated architecture around that, want to answer questions across all of their data and all of the data available to them, that is still way more difficult than it needs to be, way more difficult than the entitlement. And so I think that that's a place we're going to continue to see a big wave of innovation, both from AWS and across the industry. I think we're going to see some of the gaps in the way that especially relational databases think about identity and think about authorization become more visible as folks want to build agents. And so you want to express things like, this agent working on behalf of these 5 people. There's no way to express that in a model like Postgres's grant model, right? And so, okay, well, there's going to be a gap there. And it needs to be a gap there that we can address both with great security, but also, flexibility that is meeting business requirements. And then I think the third thing, is operational, right? Databases, we've made a ton of progress in the cloud. There are a ton of really great low operations, database options. But as we see more and more data systems being more and more automated through these operations agents, it's going to become even more necessary that those things have very simple operations, very simple security models, very simple scaling models. And, I think in a lot of ways, kind of serverless has won, even though we haven't, that hasn't really sunk in yet as agents really take over. And there does remain there remain gaps in all of the product offerings across the industry. I'm super optimistic about that one, by the way. I think it's going to be, again, a real big driver of a wave of innovation, a wave of simplification.
All right. Well, thank you very much for taking the time today to join me and share your thoughts and experiences on these various agentic patterns and the ways that the persistence layers and execution environments will help to facilitate and shape the ways that people are bringing these new capabilities to bear. So I appreciate all of the time and energy that you're putting into being an enabler for all of that. And I hope you enjoy the rest of your day.
Yeah, thank you. It's been a great opportunity.
Thank you for listening, and don't forget to check out our other shows. Podcast.net covers the Python language, its community, and the innovative ways it is being used. And the AI Engineering Podcast is your guide to the fast-moving world of building AI systems. Visit the site to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story.
And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.